Good day to all of you. Today we shall study on the topic tree traversals. My sincere thanks and acknowledgement to the authors Ellis Horowitz, Sartaj Sani and Susan Anderson Freed, the authors of the textbook with title Fundamentals of Data Structures in C. The content of my discussion I have taken from this book. This topic comes in the subject data structures and applications with subject code BCS304, which third sem students of CS and allied branches study in BE degree course. So what is tree data structure? The tree data structure is hierarchical structure that is used to represent and organize data in the form of parent-child relationship. The following are some real world situations which are naturally a tree: folder structure, the file system on a computer, the tag structure in an HTML. So the basics about the tree data structure and the terminologies involved in this topic I have covered in my previous two videos. You can refer to that. What is a tree? Tree is a non-linear data structure which organizes data in hierarchical structure, and this is a recursive definition. It is collection of node which is organized in hierarchical structure recursively. Means any data if you take, it is stored in memory. Say one data in one memory location, another data in another memory location. So several data are stored in several memory locations. These are called as nodes, and these are linked to one another, these memory locations. So they are linked in such a manner that if this is parent, this is linked with next, so that this is a child and this is parent. And if this is parent, this is child of that node. So that this kind of data structure that is called as tree. So hierarchical structure in the sense one node as parent, under that this child node will be existing. So any tree data structure has nodes and the connecting links. The connecting links are called as edges. Next, what are tree traversals? The term tree traversal means traversing or visiting each node of a tree. A tree may have many nodes and they are linked to each other. So visiting these nodes is called as tree traversal. There are three techniques: pre-order, in-order and post-order traversal technique. First, pre-order traversal. This technique follows root first, then left node and right node is visited. So that policy is followed in this. So root node is traversed before or pre to the left and right nodes, and hence it is called as pre-order traversal. The applications being, it is used to create a copy of the tree. It can also be used to get the prefix expression of an expression tree. Next, in-order traversal. So this follows left node first, then root node and right node visiting policy. So root node is traversed between left and right subtree. It is called as in-order traversal. The applications of this being to get the binary search tree nodes in increasing order. Then it is used to get prefix expression of an expression tree. Next, post order traversal. So this follows the policy that visiting left node first, then right node and lastly root node. Here root node is traversed after or post the left node and right subtree. It is called as post order traversal. The applications of this being, it is used to delete the tree, and it can also be used to get postfix expression of an expression tree. Next, we shall discuss some examples as to learn how to find the pre-order, in-order and post-order sequence for the given tree. Okay. So, considering this example 1. So, for all the three techniques, the direction in which we have to move is fixed. Starting from root node, moving towards its left, then its left. So, after leftmost, coming to its root, then moving to its right, covering its right, going back to its root, then moving down to its left, covering all the left, going to its root, right side of the tree. So then coming back to its root and next to its root and finish. This yellow marked path is fixed. So for finding pre-order sequence, these red arrow lines must be marked for all the nodes. Okay. Next, starting from here in that direction, if you move, so red arrow is cut, so we'll have to note down A node. Then in that direction, if we move, red arrow is cut, that corresponds to B node. Then similar way, this is D node. Continue in its in this path. So then continue. Then when it is cut here, it is E node. So continuing in that direction, what path is shown here or marked. So then to A, then to C, but here it is cut, so it is C, then continued, red arrow mark, so this is F, so continue in that direction. So here this is G, further if you continue, no red arrow mark, so till finish we move. So A to B, B to D, D to E, E to C, C to F, F to G. This is the pre-order sequence for the given example tree. Okay. Next, how to find in order sequence. So this yellow path starting from root node, then leftmost going till there, then continue to right, so covering left of that, then coming back here. So this path is fixed for all the three. First we have to mark this. Instead of taking left arrow marks, we take down arrow marks for all the nodes. Then starting from this point, that is root, if we move in this direction, then where it cuts down arrow, so it is cutting down arrow here, so D node we have to mark and continue the movement, so it is cut here, down arrow, that belongs to B. So then again if we cut E, so then if you continue, this is A, then again here, then F, then in this direction C, then in this direction G, then continue in that marked path, so we reach to the finish point. So D to B, B to E, E to A to F, F to C, C to G. This is the in order sequence for the given tree. Okay. Next, for post order sequence, so this yellow mark path we'll have to mark. After that, instead of left arrow lines or down arrow lines, we have to take right arrow lines. In this movement, so where it cuts the arrowed lines, so starting from here, when we move in this direction, it is cut here, so D we write. Next, when they move like this, so E it is cutting. So next here B. So next if you come this way, so E, this is F. Then in this direction if you move, it is cutting G. So in this direction C. Next the last one is A. Okay. This is the answer. That is post order sequence. Now pre-order sequence, in-order sequence and post-order sequence for the given tree we have got. This is the simplest method. Otherwise, in yellow marked path when we move, we'll have to count how many times each node is visited. In the path So we should go on noting down. If it is visited one time, we have to note that node in pre-order sequence. If it is 2, in order sequence. If it is 3, it should be noted under post-order sequence. But while counting, it may lead to some confusion. So instead of that method, this is a very simple method of finding the sequence. Okay. We shall see to one more example. This is second example. This time we shall not mark yellow path. It is shown by arrowed dotted line here. So this dotted line here, that we shall follow. Okay. So only coloring we are not doing here. That's all. Okay. So starting from this point, if we move, so left arrow which is cut first, that is A. Then if you continue, B. Then if you continue, C. So in this path if you come, D. So again continued, E. Next again continued, no. So A, B, C, D, E. So this is D. A, B, C, D, E is the pre-order sequence for the given problem. Then to find in order sequence, starting from here, this time instead of left arrow, down arrow should be written for every node. So starting from here, if we move in that shown path, so C, here down arrow is cut. So in this path next B, so in this path next D, so in this path next A, so next E. So if you continue till finish line, it is over. So C to B, B to D, D to A, A to E is the in order sequence for the given tree. Okay. Next, to find post order sequence. Now instead of left arrow or down arrow for each node, right arrow lines are marked. Starting from here in the shown direction. So this cuts C, next cuts D, then B, then E, then A, and the procedure is finished. So this is the post order sequence for the given tree. This is how for the given tree pre-order sequence, in-order sequence and post-order sequence can be found. Okay. I hope you understood. Thank you.